Okay guys, let's continue with a 1.5. We'll skip number 3 and go to number 4. At a point on the ground 60 feet from the base of a tree, the distance to the top of the tree is 15 feet less than double the height of the tree. Find the height. Okay, so we've got a tree. You're 60 feet away. It says, from that point, the distance to the top of the tree is 15 feet less than double the height. So you have double the height minus 15. It wants you to find the height. So this is a Pythagorean theorem application. So we know a squared plus b squared equals c squared. So in this case, our short legs are 60 and h. So we've got 60 squared plus h squared equals 2h minus 15 squared. 60 squared is 3,600. We have to FOIL this out. So 2h minus 15 times 2h minus 15. 2h times 2h is 4h squared. 2h times negative 15 is negative 30h. Another negative 30h. And then plus 225. Okay, so again, this is quadratic. So what do I need? I need all of my terms on one side. So I'm going to move the h squared and the 3,600 to the other side. Just a lot, but we'll be okay. That's 3h squared. When I combine these, that's minus 60h. 225 minus 3,600 is minus 3,375. This would be hard to factor, but on almost every time you do these, you should be able to divide by whatever's in front of h squared. So divide everything by 3. Like this is not much better. H squared minus 20h minus 1125. You might be thinking, yes, so now I have to find factors of 1125. So one important thing to note is two numbers are 20 apart. So that'd be like 40 times 20, but that would end in 0. 41 times 21 would end in 1. That's the only two numbers that if they end in the same digit, multiply to something ending in 5. That would be numbers ending in 5. Something like 5 times 5 is 25. So I'm looking for two numbers that end in 5. If we look, let's look at what's 20 times 40. It's 800, so it has to be bigger than 20 times 40. What's 30 times 50? 1,500, so it has to be smaller than 30 times 50, but bigger than 20 times 40, and they both have to end in 5. That leaves only 25 and 45. So you have h minus 45, h plus 25. That means either my height is 45, or my height is negative 25. So either we've got really deep roots under the tree that you're looking at, which means the ground must be see-through, or the tree is 45 feet tall. Okay, let's do some physics applications. A projectile is launched from the ground with initial velocity v feet per second. The height of the projectile is given by the equation s equals negative 16t squared plus vt, where s is the height in feet, v is that initial velocity, and t is the time in seconds after the projectile was launched. So A, find the time or times when the projectile reaches a height of 80 feet, given v is 96, so the initial velocity is 96 feet per second. Okay. So height is the s in the equation, so when is 80 equal to negative 16t squared, normally plus vt, but in this case they said v is plus 96t. Again, it's quadratic, so I need to move the 80 over. So it's minus 80. Now most of the time I'm going to pick numbers that are nice. You can divide everything by negative 16. Get 0 equals t squared minus 6t plus 5, and factor. That would be t minus 5, t minus 1. A lot of people, for some reason, put t minus 2 and 3 because they think we get the 5 and the 6 backwards. I understand why they do it. So that means t equals 5 or t equals 1. So let's think about it. Previously, we were like, oh, only one of these really makes sense. If we're talking about a projectile reaching a height, what goes up must come down. So if it crosses 80 feet going up, it also is going to have to cross 80 feet again on the way down. So both of these should make sense. The only kind of time that won't make sense is a negative time. So we can say it reaches a height of 80 feet, 1 and 5 seconds after launch. Find how long it takes the projectile to return to the ground. Well, the ground should have a height of 0. So 0 equals negative 16t squared plus 96t. There's nothing to move in this case, but I can still divide by negative 16. So we get 0 equals t squared minus 6t. Now this doesn't have a traditional factoring method because there's not a third term. But remember, there's something you're always supposed to check for when factoring. Usually we divide it out, but in this case it's a variable, a common factor. They both share a t. So this is t times t minus 6. So this is like t plus or minus 0. So this is t equals 0 or t equals 6. So it's on the ground after 0 seconds and after 6 seconds. Well, this is where it started. This is when it was launched. So it took it, the distance between those two, it took 6 seconds to return to the ground, which doesn't sound like a lot. But try throwing something in the air that's relatively heavy, it's not affected by air resistance, and see how quickly it falls to the ground if you want to measure the time. It's pretty fast. So, and there's also a number 6 problem, and you can ask about it, but usually I don't put it on the test. So that's all for 1.5.